And today I'm going to explain Kepler's law of motion and how he made them. And to explore the progress of Johann Kepler undertook his formulated his three laws of planetary motion. First is the transport. The planets orbit the sun in the counterclockwise direction as viewed from above the sun's north pole, and the planets orbit all the aligned to what astronomers call the ecliptic plane. The story is a greater understanding of planetary motion, but it could not be told if they were not the work of German mathematician named Johann Kepler. Kepler lived in Graz, Austria during the tumultuous early 17th century. Due to religious and political difficulties common during that era, Kepler was banished from Graz on August 2nd, 1600 CE. Fortunately, an opportunity to work as an assistant for famous astronomer Tycho Brahe presented himself, and the young Kepler moved his family from Graz 300 miles across the Danube River to Brahe's home in Portugal. Tycho Brahe is credited with the most accurate astronomical observations of this time and was impressed with the studies of Kepler during the earlier meeting. However, Brahe mistook Kepler, fearing that his bright young intern might eclipse him and premier astronomer on this day. He therefore let Kepler see only one part of his voluminous planetary data. This is Kepler with Tycho Brahe. Next, he set Kepler to the task of understanding the orbit of the planet Mars and the movement of which fit planetary problemally into the universe, as described by Aristotle and Ptolemy. It is believed that the part of the motivation for giving the Mars problem to Kepler was Brahe's hope that this difficulty would occupy Kepler. While Brahe worked on his own theory of the solar system, which was based on the geocentric model, where the Earth was the center of the solar system. Based on this model, the planets Mercury, Venus, Mars, and Jupiter and Saturn all orbit the Sun, which in turn orbit the Earth. As it turned out, Kepler, unlike Brahe, believed firmly in the Keplerian model of the solar system, known as heliocentric, which was correctly placed the Sun as its center. But reasons Mars orbit was problematic was because the Copernican system incorrectly assumed that the orbit of planets to be circular, and in that time Neptune was not discovered as they didn't have a telescope to see that far. After much struggle, Kepler was forced to an eventual realization that the orbit of the planets are not circles, but were instead the elevated and flattened circles that geometers call ellipse. At the particular difficulties Brahe's had with movement of Mars were due to the fact that its orbit was the most oblique planets for which Brahe had extensive data. Thus, in a twist of irony, Brahe unwittingly gave Kepler the very part of his data that would enable Kepler to formulate the correct theory of the solar system, banishing Brahe's own theory. Since the orbits of planets are eclipsed, let us review the three basic properties of ellipse. The first property of an ellipse. An ellipse is defined by 2 points, each called focus and together called foci. The sum of the distance of the foci from any point of the ellipse is always constant. The second property of an ellipse. The amount of flattening of the ellipse is called the eccentricity. The flatter the ellipse, the more eccentric it is. Each ellipse has an width value between 0, a circle, and 1 essential, a flattened line, technically called a parabola. The third property of an ellipse. The longest axis of the ellipse is called the major axis, while the shortest axis is called the minor axis. Half of the major axis is termed as a semi-major axis. Knowing then the orbit of the planets are elliptical, Johann Kepler formulated three laws of planetary motion, which accurately describe the motion of comets as well. Kepler's law of planetary motion. Kepler's three laws describe how planetary bodies orbit the sun. They describe how planets move the elliptical order with the sun as a focus. A planet covers the same area of space in the same amount of time, no matter where it is in the orbit. And a planet orbital period is proportional to the size of its orbit, its semi-major axis. Kepler's third law, first law. Planets move in elliptical order with the Sun as a focus. Each planet's orbit about the Sun is an ellipse. The Sun's center is always located at one focus of the orbital ellipse. The Sun is at one focus. The planets follow the focus in its orbit, meaning that the planet to the distance is constantly changing as the Sun goes around its orbit. Example of Kepler's first law. Kepler's second law. A planet covers the same area of space in the same amount of time, no matter where it is in its orbit. The imaginary line joining a planet and the sun's we sweep equal areas of space during equal time intervals. As the planet orbits, basically that the planet do not move with a constant speed along their orbits. Rather, their speed varies that the line joining the center of the sun and the planet sweeps out equal parts of area in equal times. The point nearest approach to the planet to the sun is termed as perihelion. The point of the greatest separation of aphelion, hence Kepler's second law. A planet is moving fast when it's in the perihelion and slowest in aphelion. Example of second law. This is aphelion and this is a perihelion. Kepler's third law. A planet orbital period is proportional to the size of its orbit. The square of the orbital period of these planets are directly proportional to the cubes of the semi-major axis of their orbit. Kepler's third law impels that the period for the planet to orbit the Sun increases rapidly with the rapid of its orbit. Thus, we find Mercury, the innermost planet, takes only 88 days to orbit the Sun. The Earth takes 365 days, while Saturn requires 10,759 days to do the same. Though Kepler hadn't known that gravitational when he came up with these three laws, they were instrumental in Isaac Newton devising his theory, the universal gravitation, which explains the unknown force behind Kepler's third law. Kepler and his theories were crucial in the better understanding of our solar system, dynamics and spin modes to newer theories that accurately approximate our planet's orbits. This is an example of Kepler's third law. And thank you.